I just updated my benchmarks on the 9060 XT 16GB, 5060 Ti 16GB, and 9070 GRE, and you can compare them all in this video in the latest games of 2025 and 2026 at multiple graphics settings, not just max settings, as well as native resolution and with upscaling. And the GPU models I'm looking at here are the 9070 GRE Sapphire Pulse version and the Asus Prime 9060 XT, and then the PNY 5060 Ti 16GB. All of these were received as review samples, and all of them are running at their out-of-the-box settings on a high-end 9800X 3D based system for benchmarking. Now, some of you are just going to want the too long didn't watch version of the video, so here's some overall results, and then we'll get back to the side-by-side footage and some final thoughts. So if you look at the 5060 Ti and the 9060 XT 16GB, head-to-head, this is their average FPS in all of the tests that I ran here. Again, it focuses on the latest games, 2025 and 2026, and native resolution and balanced level upscaling, FSR versus DLSS, and then also looking at some reduced graphics settings in addition to maximum graphics settings in most games, but that's a lot to process. So another way you could look at this is the percentage difference between the GPUs in each of those tests. If you look at it that way, I've assigned the positive values to the Advantage 5060 Ti and the negative values to a percentage deficit for the 5060 Ti against the 9060 XT 16GB. You can see that the 5060 Ti is usually ahead, although it's typically in like a, 3 to 7% range, although does have some games with double-digit leads, especially when path tracing, which is what the Cyberpunk test was used for. However, on average, using the geomean for the average FPS in all the games puts the 5060 Ti 16GB 7% faster than the 9060 XT 16GB in this suite of games. Now, if you instead were more interested in how the 9070 GRE stacks up against the 5060 Ti, that's also available here as well. And honestly, that's the more fair comparison from a price perspective. The 9070 GRE costs $550 and then up from there. And the 5060 Ti 16GB also costs about, well, actually $565 and then goes up from there. It seems like it's production is kind of reduced given the RAM prices and everything like that being kind of out of control. So the 5060 Ti 16GB costs actually more than the 9070 GRE in the current market, and the 9060 XT 16GB version is certainly the value leader here at $430 out of this lineup. So certainly keep these prices in mind when we're looking at these comparisons. So anyway, 9070 GRE, which is actually more the price match for the 5060 Ti 16GB, we can see those red bars generally well ahead of those green bars. And if we look at it as the percentage difference in each test, what we're seeing here is that the 9070 GRE is on average 19% faster than the 5060 Ti 16GB, although not in path tracing, where the 5060 Ti is taking the lead. The 9070 GRE trails by 11%. However, the 5060 Ti is not really a path tracing powerhouse or anything like that. So if this was the head-to-head, you'd probably think, wow, the 9070 GRE is the way to go. But do remember that the real problem with the 9070 GRE isn't its matchup with the 5060 Ti 16GB, it's that the 9070 non-GRE version starts to have some models right here at $580. So for only $30 more, you get a significantly more powerful GPU that has 16 gigabytes of VRAM instead of 12 on the GRE. And then you could also compare against the 5070 from Nvidia at $600. Yes, it is $50 more, but it's also more powerful. You get the Nvidia feature set. So there's some tough matchups there. And I've already done detailed head-to-head videos that cover those matchups. But I do think it's important to bring it up here when we're talking about the 9070 GRE. But in today's video, we're focusing on the 5060 Ti 16 gigabyte, 9060 XT 16 gigabyte, and then throwing in that 9070 GRE here as well. Now, if we want to look at the AMD products up against each other, we're seeing the 9070 GRE and the 9060 XT 16 gigabyte. I kind of used the lighter orange color for the GRE and the red for the 9060 XT 16 gigabyte. You can see that the GRE, despite having 12 gigabytes of VRAM instead of 16, is generally noticeably faster. And if we look at it as a percentage difference, you can see that on average it's about 28% faster. Now, if we think of that as price scaling goes, it's $550 for the GRE versus $430 for the 9060 XT 16 gigabyte. So 28% more money for 28% more performance, although losing 4 gigabytes of VRAM. So there's a little bit of trouble right there. So basically, these GPUs are offering from AMD about the same performance per dollar, but the issue is that the more expensive one is also offering you less VRAM. So to make up for having less VRAM, I think it would make sense for it to come in at a lower price. I think overall the 9070 GRE would be a much more attractive offering at $500 or less to make up for having less VRAM versus the 9060 XT 16 gigabyte, or to give it a little more price separation between the baseline 9070 non-GRE version. Now, my pessimistic outlook is that really the 9070 non-GRE version is probably just going to go up in price, and maybe that's why they came in at this price with the GRE. But it is what it is right now, as we're seeing on the current market. Now, let's go ahead and actually look at the detailed side-by-sides, because some things don't fit into the bar graphs. Like, for example, the fact that certain games only allow path tracing to be enabled on Nvidia GPUs. Well, should you care in this price bracket? Well, the 5060 Ti 16 gigabyte is not really a path tracing powerhouse, where in Resident Evil Requiem at 1440p max plus path tracing, even using DLSS balanced, only comes in at around 42 FPS in more demanding scenes. Probably not the frame rate most people are looking at. You could use frame generation to try to kick it on. From there, in a single player title, maybe that's fine. But now if we look at the max settings that all GPU vendors are allowed to use, and I hate that only Nvidia is allowed to use path tracing here, but it is what it is. But we're looking at max settings with the RT set to high, native resolution. Here we're seeing 39 FPS on the 9060 XT, 44 FPS on the 5060 Ti, and 50 FPS on the 9070 GRE. So the 5060 Ti is 13% faster than the 9060 XT, and the GRE had an even larger lead from there. None of them were getting super high frame rates, so you might want to kick on DLSS and FSR4 at the balanced settings. And if we do that here, we're now getting 67, oh my goodness, FPS on the 9060 XT, 12% faster on the 5060 Ti at 75 FPS, and the 9070 GRE takes a 30% lead over the 9060 XT at 87 frames per second. So now it's very playable on all of these GPUs and just kind of scaling up as you go. If instead you turn ray tracing off and go down to the normal preset, now we're getting 81 FPS even at native 1440p on the 9060 XT, and the 5060 Ti's lead drops to 4% at 84 FPS versus 81. The 9070 GRE is the furthest ahead at 107 FPS, giving it a 32% lead over the 9060 XT 16 gigabyte version. So we can see turning off the ray tracing certainly dropped the 5060 Ti's advantage. Now, another big game released this year is Pragmata, which is also another game from Capcom, like Resident Evil Requiem, which has a path tracing mode, but it does not allow you to enable it on any GPU vendor besides Nvidia. That being said, even with DLSS balanced on a 1440p output, we're only hitting about 45 FPS here, so I probably wouldn't factor that much into my decision unless I was buying a more powerful GPU. Now, if we go to the otherwise max settings, which is called the quality preset, which does include ray tracing by default, and this is native resolution, not quality upscaling, it's just the preset's called quality. It's 74 FPS on the 9060 XT, 77, so a 4% lead on the 5060 Ti, and the 9070 GRE is hitting 100 FPS, giving a 35% advantage over the 9060 XT in this game, and despite ray tracing happening, Nvidia only taking a 4% lead. Now, if we kick on DLSS and FSR4 balanced on that same maximum preset, still including ray tracing on a 1440p output, it's 98 FPS on the 9060 XT. The 5060 Ti's lead gain grows to 7% at 105 FPS, and the 9070 GRE has 129 FPS, giving it a 32% advantage over the 9060 XT 16GB version. Now, I also tested this game out at reduced settings. This is the balanced preset. This is native resolution. I am not using balanced upscaling here. It's just the preset name is balanced. And this preset does not include ray tracing by default, so I did leave ray tracing off. The 9060 XT hits 86 FPS. The 5060 Ti hits 91 FPS, giving it a 6% advantage over the 9060 XT. And the 9070 GRE hits 114 FPS, making it 33% faster than the 9060 XT. If we kick on balanced upscaling on the balanced preset using DLSS and FSR4, we now see 112 FPS on the 9060 XT, and the 5060 Ti is 5% faster at 118 FPS. The 9070 GRE hits 148 FPS, making it 32% faster than the 16GB 9060 XT. Now, I also tested out Cyberpunk. This is the oldest test in my testing suite for this video, but it is a game that allows path tracing to be enabled on all GPU vendors. So I did that just to get one path tracing benchmark onto the charts to capture that aspect of the GPU's performance. Now, the 5060 Ti is only hitting 47 FPS, but that does put it 52% faster than the 9060 XT at 31 FPS, and the 9070 GRE is hitting 42. So it's slower than the 5060 Ti here, but none of them were getting that great of an experience. Another one of the biggest releases of 2026 is Forza Horizon 6 at 1440p max settings. That's extreme plus the highest levels of ray tracing. We're at 39 FPS on the 9060 XT, 44 FPS on the 5060 Ti, making it 13% faster than the 9060 XT here. And the 9070 GRE is at 48 FPS, making it 23% faster than the 9060 XT, which is a smaller lead than usual, probably running out of 12 gigabytes of VRAM there. Now, if we kick on DLSS and FSR4 balanced, we're suddenly reaching good frame rates on the otherwise maxed out settings with the Extreme plus RT 1440p output. The 9060 XT hits 63 FPS, the 5060 Ti has an 8% lead now at 68 FPS, and the 9070 GRE hits 74 FPS, so it is the fastest here, but it also gets some frame time spikes the other ones don't, and it's only 17% faster than the 9060 XT here, showing its 12 gigabytes of VRAM is causing it some trouble in this game at those settings. At 1440p extreme settings, no ray tracing, but also no upscaling. It's 80 FPS on the 9060 XT. 5060 Ti is actually slower now by 1% at 79 FPS. The 9070 GRE is 16% faster at 93, but again, that's kind of suppressed lead is indicating there's probably some VRAM issues, so it's not getting as big of a lead as it usually does. Kicking on DLSS and FSR4 balanced, we're now seeing 97 FPS on the 9060 XT. The 5060 Ti is 2% faster at 99 FPS, and the 9070 GRE is hitting 110 FPS, but only puts it 13% faster than the 9060 XT. So again, this could be an indication that VRAM could be playing into the lead not being as high as it usually is compared to the 9060 XT. Moving on to another one of the biggest releases of 2026, we have Crimson Desert at its maximum settings. That's 1440p cinematic, plus if you enable the ray reconstruction or ray regeneration, that does also kick on a higher level of ray tracing. I'm using DLSS and FSR4 balanced here rather than native, but we're still only reaching 29 FPS on the 9060 XT and 34 FPS on the 5060 Ti. It is 17% faster than AMD here, but neither one is very playable. The 9070 GRE is hitting 39 FPS, but still not a great result. At 1440p and dropping to the Ultra preset and turning off the ray reconstruction and ray regeneration, this still is using ray tracing, but a reduced ray tracing setting on the Ultra preset. It's 50 FPS on the 9060 XT. The 5060 Ti is 12% faster at 56 FPS, and the 9070 GRE is the fastest at 65. It's 30% faster than the 9060 XT 16GB, and no signs of 12 gigabytes of VRAM being an issue here. At 1440p Ultra, again, that does include ray tracing, but with DLSS and FSR4 at the balanced preset, we jump to 68 FPS on the 9060 XT. It's almost a tie. The 5060 Ti is 3% faster and 2 FPS faster at 70, and then the 9070 GRE takes a 26% lead over the 9060 XT at 86 FPS, although I don't really like the look of any of the upscalers in this game. As the foliage moves, it kind of looks smeared. In Call of Duty Black Ops 7 at 1440p balanced preset but native resolution, we're getting 163 FPS on the 9060 XT, which does make it significantly faster than the 5060 Ti, which is only reaching 88% of the 9060 XT's performance at 143 FPS. The 9070 GRE is hitting 198 FPS, putting it 21% faster than the 9060 XT at these settings in this game. Now, we could also kick on balance level upscaling on the balanced preset, and that boosts the 9060 XT to 172 FPS, and the 5060 Ti closes some of the gap but doesn't catch up with 161 FPS, reaching 94% of the performance of the 9060 XT. The 9070 GRE is 26% faster than the 9060 XT at these settings, reaching 217 FPS, but honestly, all of these GPUs are fast enough that if you're not getting the kill, it's a skill issue, not a frame rate issue. Now, another big multiplayer title from the end of last year was Battlefield 6, here at 1440p max settings native resolution. It's 61 FPS on the 9060 XT and 69 nice on the 5060 Ti, which is 13% faster here. And this game does seem to show a bit of a more than typical Nvidia advantage when playing at the maximum overkill preset. The 9070 GRE is 38% faster than the 9060 XT here at 84 FPS. Now, if we kick on DLSS and FSR balanced, but keep the overkill preset and the 1440p output, the 5060 Ti's lead grows. The 9060 XT is hitting 83 FPS, which is certainly very playable, but the 5060 Ti is hitting 98 FPS. That's an 18% advantage. Whereas the 9070 GRE is hitting 115 FPS, which is 39% faster than the 9060 XT. But again, all the GPUs are doing well here. Now, interestingly, when I drop to the medium preset, which might be more how you'd play a multiplayer competitive game, the 5060 Ti's lead drops, and I've noticed this on other AMD versus Nvidia videos, where at the medium preset, there's less of an Nvidia advantage than compared with the overkill settings. The 9060 XT has 106 FPS versus the 5060 Ti's 110, so 4% lead for Nvidia there, and the 9070 GRE is hitting 140 FPS, putting it 32% faster than the 9060 XT. If we use balanced level upscaling, and I guess I forgot to type in FSR4, but yeah, DLSS and FSR4 at the balanced preset, the 9060 XT is hitting 136 FPS, the 5060 Ti reaches 144, making it 6% faster, and then the 9070 GRE is hitting 177 FPS, which is 30% faster than the 9060 XT here. By the way, I'm using the campaign in the first mission as the benchmark here, since getting multiplayer footage to line up is difficult, but it's the same engine and all that. Now, Marvel Rivals, another popular multiplayer title, is 1440p Ultra settings, native resolution, 53 FPS on the 9060 XT. The 5060 Ti is 4% faster at 55 FPS, and the 9070 GRE is hitting 68 FPS, putting it 28% faster than the 9060 XT at these ultra settings at native 1440p, which might not be the settings you would realistically use on a competitive multiplayer game. So turning down to the medium preset at native 1440p, we're hitting 80 FPS on the 9060 XT, and the 5060 Ti is taking a 9% lead now at 87 FPS. The 9070 GRE is hitting 105, putting it 31% faster than the 9060 XT. And I didn't test upscaling in this video on these GPUs because on the GRE, for some reason, visually it looked like I had FSR 3 enabled rather than FSR 4, so I didn't feel like that was a fair matchup. Now, taking a look at last year's Game of the Year with Clair Obscur Expedition 33, 1440p epic settings are hard to run in Unreal Engine 5, so we're looking at 36 FPS on the 9060 XT versus 37 on the 5060 Ti, so 3% and 1 FPS lead for Nvidia there. The 9070 GRE is hitting 46, which is 28% faster than the 9060 XT, but still not an amazing way to play this game. However, with DLSS and FSR4 on the balanced settings and a 1440p output and epic settings, we're now over 60 FPS on all the GPUs, with the 9060 XT hitting 62 FPS, the 5060 Ti is still 3% ahead at 64 FPS, and the 9070 GRE is 23% ahead of the 9060 XT at 76 frames per second here. So you can use the maximum settings in this game as long as you're willing to use balance level upscaling to break 60 FPS. But you could turn down to medium settings at native 1440p and have roughly the same performance. You're at 61 FPS now on the 9060 XT versus 65 FPS on the 5060 Ti. That does give it a 7% lead now for Nvidia. And the 9070 GRE is hitting 77 FPS. That puts it 26% faster than the 16GB 9060 XT here. Now, you could also use balance level upscaling on the medium settings with a 1440p output to get a nice high refresh rate experience on these GPUs. The 9060 XT is now reaching 95 FPS, putting the 5060 Ti 6% ahead at 101 FPS. The 9070 GRE is 19% ahead of the 9060 XT here at 113 frames per second, and I think that is all of the benchmarks that I ran for this video. So overall, once again, the real factor here is the prices, I think, because at least in the US market, I know the 9070 GRE is close in price to cards like the 5070 or the 9070, non-GRE version coming in at $580. So while the GRE looked pretty good up against the GPUs it was compared against here, remember to check out my comparison videos against those other GPUs from AMD and Nvidia that are closer to its price point. The 5060 Ti 16GB at its current United States pricing looks pretty bad. At $565, you could get, a 5070 for not much more money, or a 9070 from AMD for not much more money. That would be 16GB of VRAM, or for slightly less money, you could get that 9070 GRE. It's just tough to recommend up against the other products. But like I said, in AMD's own product stack here, the 9070 GRE at $550 versus the 9060 XT 16GB version, if I could type things in correctly, at $430. Well, like I said, you're getting about 28% more performance for 28% more money, but you also lose out on VRAM on the more expensive card, which kind of feels bad. And then there's that 9070 non-GRE version. That's a pretty close price competitor there. So hopefully you guys found all of these benchmarks useful and or interesting. I would say that all of these cards are very usable 1440p cards, occasionally having to turn down settings and or resolution, but using DLSS or FSR4 is looking pretty good these days. And really the 12 gigabytes of VRAM on the GRE was only really showing problems noticeably in the benchmarks on games like Forza Horizon 6, but it can pop up in some other games as well. So anyway, that's what I've got for you guys today. If you're curious about these, I would say that my favorite of these three GPUs at current prices in the United States market is the 9060 XT 16GB, because it's getting you a 16GB card with good 1440p performance in the latest games for closer to $400 rather than closer to like $550 to $600. So and certainly the value comparison for the 9060 XT up against the 5060 Ti 16GB goes in AMD's favor here, because the 5060 Ti 16GB pricing is just out of control. At $565 versus the $430 on the AMD competitor, you're spending 31% more money For the Nvidia GPU, it has the same amount of VRAM. I do prefer the Nvidia feature set, but it's 31% more money, and I only found it 7% faster in this benchmark suite, which does include a lot of ray tracing, including a path tracing title. I would say a more typical result is about 5% faster or so. For 31% more money, it's hard to recommend that, and even if you were going to go the Nvidia route, at that price point, I'd probably go with the 5070 despite its lower VRAM capacity against the 5060 Ti 16GB, and I have a head-to-head updated video on that matchup as well. Anyway, I think I've said enough. Hope you guys found the video useful and or interesting, and I hope all of you have an excellent day.